Hello, guys, welcome to day 10. For you to have come this far, you've actually learned a lot. Today we are going to be doing something very interesting, and today we are going to be solving problem 6, which was the assignment given to you yesterday. Problem 3 is going to be given to you as an assignment for you to submit today. So this is just a solution to the assignment that was given to you yesterday, and I'm going to be solving that for you. Alright, so the problem says the sum of the square of the first 10 natural number is this. That is, you're trying to sum, that is, when you sum the individual square of each of the natural numbers below 10, you have this. Then when you now sum up all those natural numbers and then square them, you have this. That is, the square of the sum of the first 10 natural number is this. Now, the difference between the two of them is now 2640. That is, the difference between the sum of the squares and then the square of the sum. That is this. Now the problem now is find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. Now to do this is actually a very simple problem. Now in order to be able to actually run this problem or solve this problem, the only thing our problem needs to know is, do you want to find for 10, or do you want to find for 20, or you want to find for 100, or you want to find for 200? That is, it just needs just a single input. So now let's go to our Python, our editor, to just write some programs. So I'm just going to, our function, I'm going to call it sum square, and then I'm going to pass n as the only input argument. Now because it only needs just a single value to work, the other things are just going to be things it generates on its own. So the first thing I would love us to do is, let's have I to be equals to 0, and then let's say while I is less than or equals to n, because when you're trying to compute, if you go back to Project Euler here, it's the value that you're trying to consider, which is whatever it might be, must be inclusive. So if n is 10, then 10 must be inclusive. If 20 is the gauge, then 20 must be inclusive. All right, so let's get back to and that's the reason why we have the less than or equals to n, because if we say less than, if we strictly say I less than n, that means we are not including n. All right, so now another thing we need to do before we move on is we need a variable called the sum of the individual squares, and then the sum of all the values, then the square of it. So let us have x to be let's say sum of the individual squares, and then let us have y to be equals to 0, which is the sum the square of the sum, right? So now let us go ahead with our program. So we can basically say x plus equals to POW is either we can basically say okay, POW I comma I comma 2. Now it's either you say POW I comma 2, or you say I star star 2. So this is what this guy is basically going to be doing. It's going to be appending the square of every number. For 0 is going to say 0 squared plus 0, that's 0. 1 squared plus 0, that will be 1. Then 2 squared, that is 4, plus initially 1, which is 1 squared, that will be 5. And then it keeps doing that until it gets to n, which is in this case 10, which is our test case. Then we can now say y is basically then the addition of all the values. So we can basically say at the end of our program, we want to always increment our I, which is because we always want this program to end somewhere. We want it to end once this is false. All right, so we can basically return POW the square of the sum, which is y comma 2, then minus x. Now the reason why I'm squaring y is because y is just basically 0 plus 1 plus 2 plus 3 plus 4 up to n. So we need to square it. based on what we have here. So 1 plus 2 plus 3 up to the value of n. In this case, our n is 10, so it has to be squared, and then it needs to be subtracted here. So let's go ahead to test our program. So let's just say test is equals to sum square 10. Let's just print test, right? So save and then run your program, and then when you run your program, it says 2640. So Project Euler tells us the answer is 2640, so we actually got that. So now we can go ahead to test for 100. So when we go ahead to test for 100, let me just put 100 here, save, and then run F5. So our editor basically tells us the answer is 251641150. So it means the answer to this problem is actually that. So one thing I just want you guys to just understand is problems like this, you need to first of all calm down, know what are the inputs, what are the things you need in order to solve this problem. In this case, all you need is just the last number, the gauging number, which is n. So in this case, n can be 10. If n is 10, your answer should be 2640. If n is 100, then your answer should be 251641150. I want to believe you've been able to learn a lot. Try out problem 3, and then see you tomorrow. Bye.